This video is for licensed and trained HVAC technicians only. Do not attempt any of these procedures on your own. Call the professionals.
Hey guys, it's Eddie. I want to shoot you another quick little video. I had a question today about 2-speed air conditioners, so rather than try to answer it, I figured I'd just shoot a quick video on it. What I'm hoping to show you today is the pressure differences between high stage and low stage, the BTU differences, airflow differences, the wattage, the amp draws, the voltage. I'm just going to measure everything, then I'll write it all out on paper and we'll compare the two. That way you can see when you're working on 2-stage air conditioners what you can expect. Alright, so let's get started. Infinity stat for my checkout mode. So what I'm going to do is I'm going to go down here to checkout. I'm going to go down here to heat pump cooling. I'm going to go for, I'm sorry, I'm trying to look over my shoulder here. I'm going to set it up for 15, let's go for 20 minutes each. And what's going to happen is my high stage cool is going to come on, my airflow is going to adjust, and I can get some readouts here, static pressure and yada yada. So, alright, so let me get back outside to the outdoor unit and we'll see and record what the high stage is doing. Right now it's running in high stage. We got 127 pounds over 371, right at about 8 degrees superheat, 10 degrees subcool. It's roughly probably about 80 degrees or so out here right now. 51 degrees, 100 degrees, line sets. My coil temperature is 44. Condensing temperature is 111. So this is running in high stage. I'm going to go ahead and print this out. First thing I want to get is my volts. I'm measuring right off my contactor at 240 volts. Then my amps, I'm at 11 amps. And my watts, 2600, right at 2680. This is on high stage. Here's my readout. CFM's 1051, 35,000 BTU. My airflow on my thermostat says it's 1100 CFM, and what I just measured was right here, it's 1050. So it's off 50 CFM, so it's not that bad. Just a minute, you're going to hear my compressor kick off. Alright, it's going to shut off for a little bit, then it's going to kick back on. At that time it will be in low stage. Alright guys, the compressor just kicked off. It's going to stay off for just a few seconds. Alright guys, the compressor just kicked back in. Now it's going to run in low stage. Here we are in low stage. You're going to notice my pressure is at 141, 316. My line temperatures are 57 and 95. My superheat's 8. Subcooling's almost 4. And my coil temperature indoors 49. My outdoor coil temperature is 95. Well, I'm sorry, 99. So let me record these. I'm going to go downstairs and measure for the BTU and airflow, and I'm also measuring wattage of the motor. I'll be right back. So here's my voltage. It actually went up. I am now using 241.8 volts. I am drawing 5 amps. I am using 1190 watts. 1192 watts. Alright guys, again I've got the printout from the Testo 435. I measured all my airflow, my temperatures. I got the pressures of from my 570s. So everything's recorded. And I'm going to start off with my suction. On low speed, it was running at 138 pounds. On high speed I was running at 27 pounds. My indoor coil on low speed was at 48 degrees. On high speed my indoor coil was at 43 degrees. My suction line temperature on low speed was 55, high speed was 51. Superheat was 7 degrees. My voltage outdoor unit was 241. My amps was 5.26. It gave me 1192 watts. Now, if I go over here to my discharge sides, it's my high side. Low speed, I was at 312. High speed, I was at 372. My outdoor coil temperature on low speed is 98, 111 on high speed. My line temperature was 96 versus 109 or 100.9. My subcooling 2.7. This is why it's really important that you only charge your air conditioner in high speed. Do not charge your air conditioner on low speed. You're going to overcharge it. My voltage was 240, amps 11, so I was pulling 2680. Alright, so let's start off with the indoor. This is on low speed. I had 680 CFM. I was 18,000 BTUs. My return temperature was 74 degrees. My humidity is 53%. My wet bulb was 63 degrees. Supply was 55 degrees. Humidity 90%. Wet bulb was 54 degrees. My blower watts was 80. Alright, this is on my high side. My CFM was 1051. My BTU is 35,300. Return of 74 degrees. Humidity is 53. Wet bulb 63. My supply was 54 degrees. Humidity 79%. Wet bulb 51 degrees. My blower watts was 180. If you look at this is my BTU on my low speed. My total watts was 1272 and my EER value was 14. Now over here on my high speed, my BTUs was 35,300. My total watts was 2860 and my EER was 12. So we went from a value of 14 to a value of 12 between low and high. There's one thing I do want to add on these blower motors. If you notice these wattage, these are variable speed blowers. On low speed, these things are running at 80 watts. You know, in other words, that's using the same watt as a 80 watt light bulb. It uses the same power. This one uses 180 watts, which is lower than 200 watt light bulb. So these blower motors are really efficient. But you know, these are the totals. I hope it helps you out, and we'll see you on the next video.